Good morning. We're going to get started. Thank you all so very much for coming to this 9 a.m. session. It's a turnout that I'm pleasantly surprised with. You guys flatter us. My name is Cosmos Darwin. I'm a program manager on the high availability and storage team within Windows Server. Today, I'm joined by Andrew and Garrett, who are also program managers on the same team. And we're here to talk about how you can be an IT hero with Storage Spaces Direct. We're going to start by looking at some stories of customer success. We have a couple of great ones that I'm excited to share with you. Then we're going to dive into Storage Spaces Direct, what it is, how it works, why it's so exciting. We'll talk about industry-leading performance, as well as its many enterprise-grade features. Then we'll talk about manageability. We have a lot of news this year to share with you. And then last, but of course very important, we'll talk about cost and hardware. So that's kind of our outline for this session. Does that sound good? Yeah? Great. Let's get started then with some stories of customer success. I have 3 of them that I'd like to share with you this morning, and there's a theme that you're going to see that sort of goes through all 3 of them. So I want to call that out first so that you can look for it. And that is that Storage Spaces Direct delivers truly industry-leading performance for the most affordable price. This is something I think you'll see come up over and over again in these stories. OK, so we have 3 stories. The first one is Youth Villages, and then we'll talk about King County Library, and then Create Advertising. So let's start with Youth Villages. Youth Villages is a nonprofit organization dedicated to helping emotionally and behaviorally troubled children and their families to live successfully. Earlier this year, they chose to deploy Storage Spaces Direct for their electronic medical records system to replace a SAN that they had before. This system serves over 150,000 patients. Talk about impact, and their 2,800 staff. Now, by going with Storage Spaces Direct instead of the alternative, which was to replace the SAN that they had, they cut their storage costs in half. Their CIO tells us they saved $150,000 in doing so. Now, I want to remind you, this is a nonprofit. These guys have better things to do with that money than go out and buy a SAN. But it's not just about cost savings. Youth Villages uses a Hyper-V cluster of 7 servers, which runs all of their applications and workloads, and then they used their SAN as storage. And by going with a scale-out file server architecture with Storage Spaces Direct, they were able to swap out the SAN and replace it with Storage Spaces Direct without making any changes to their Hyper-V cluster. So it was a seamless transition to software-defined storage. Now, I mentioned cost savings. They also, by switching to Storage Spaces Direct, saw their storage performance increase by a factor of 30. To quote the director of IT, everything runs faster. And that means that their employees can focus on doing what they do best and what I think you'll agree with me, what matters most, and that's helping troubled youth. So that's Youth Villages. That's just one story, one of many. Let's talk about King County Library now. King County Library is actually my library. They have a branch across the street from where I live in Seattle. It's one of the largest county library systems in the United States. They serve over 1.4 million residents, including yours truly, with their 49 locations across the state of Washington. And earlier this year, like Youth Villages, they chose to adopt Storage Spaces Direct. They chose to adopt hyper-converged infrastructure powered by Hyper-V and Storage Spaces Direct. And they did that to replace their aging iSCSI SAN. Eric, the systems engineer from King County Library System, whom we worked with, tells us that the new Storage Spaces Direct solution is a lot faster and a lot more responsive. But it's not just about performance. By going to hyper-converged infrastructure, King County Library was able to consolidate 3 of their existing clusters into a single cluster, thereby eliminating 15 servers. And that reduction in data center footprint, that's not just savings of capital expenditure up front, but that's money that they're going to save for years to come in the form of lower power costs, less cooling, even less operational costs just in general. OK, so that's 2 of our stories now. Let's talk about Create Advertising. And for this one, we have the distinct pleasure of having a guest here from Create to tell us about it. So please join me in welcoming Anthony Hoyt, Systems Architect from Create Advertising. Hey, Anthony.
Hello.
Thanks for being here. So Create is based, you guys are based in LA and Hollywood.
That is correct.
Can you tell me a little bit about what you guys do?
Well, we are primarily a trailer house, but we have many departments in graphics, visual effects, and in VR.
So you guys make trailers for?
For studios, Disney, Marvel, Sony. If there's a studio out there, we've probably worked with them.
Oh, that's very cool. So what are some of the challenges or some of the demands that kind of a workflow places on your IT infrastructure?
Well, we have to ingest terabytes of footage and have access to that all on the fly for as many as 35 editors.
So you guys have 35 editors. They all need to work on this footage that you're ingesting, and then they're gonna, forgive me here, they're gonna like snip it together and produce movie trailers out of it, right? Cool. All right. So recently, under your leadership, Create moved to a software-defined storage solution. Is that right?
That is correct.
So can you tell us a little bit about the solution you went with?
So we built a 4-node cluster. We have about raw 960 terabytes. 450 of that is usable. And we have 2 NVMEs in each system with 24 drives in each of the JBODs.
So you said it's a 4-node system.
4-node cluster, yeah.
And then you have JBODs here. So are those JBODs just one attached into each?
Direct attached to each node.
OK. And then storage space is direct on top of that. And it gives you said, about half a petabyte of usable space. And that meets your needs then?
Totally, yeah.
OK. So you are, if I'm not mistaken, you're not hyper-converged, right? So
no, it's a scale out.
OK, so you guys are taking that storage from storage spaces direct and you're exposing it over SMB3 file shares?
That is correct.
And then people on the workstations edit the files directly on there. OK. Now I see from this diagram that the workstations are Windows 10 Pro. So I have a bit of an arts background, and if I can get away with saying this on a Microsoft stage, usually in industries like this, people are using Apple computers, right?
Yes, for a long time.
So you guys were you guys using Apple computers, or what's
the whole facility was Mac-based when I first arrived, and my job was to remove all of that and use Windows 10 and Microsoft and all of the platforms.
So I love to hear that. So you guys replaced your storage with Storage Spaces Direct, and then you replaced all of your workstations. You got rid of your Mac Pros and you replaced them with Windows 10 Pro. What was the reason for that?
Primarily performance and cost.
OK, so was it kind of like a better together story, or?
Yeah, we have SMB, with SMB3 you have RDMA, we have much faster access to the storage, and the Storage Spaces Direct platform.
So did you guys, did you put RDMA NICs then, I guess, in
the workstations as well?
In the workstations
and
as well.
in the,
cool.
In the servers, obviously.
That's awesome. OK, so that's kind of the what. How did that work out? Like, what did you guys see in terms of, first of all, how did the cost compare?
Well, the cost of our previous system cost almost 4 times as much as the one we did now, and the performance was much lower on the older system.
So you guys, you're saying that basically, if I put this in like shopping mall terms, for every dollar you spent, you saved $3?
Yes.
Wow. And you said the performance was actually better.
Yeah, 4 times better.
So you got 4 times the performance for 1/4 of the cost.
Yeah, and the scaled performance from each node to the server was faster as well. So the more machines we had accessing it, the faster the total storage performance was.
And that wasn't the case before, or?
No.
Oh, wow.
Not at
Great.
all.
I love to hear that. So, talking about cost or performance, those are kind of like technical outcomes. But I have a quote here from Chris, and I think Chris is your boss, I think.
Yeah, he's the director of technology.
And he says, using Storage Spaces Direct, we can have multiple video editors working on a trailer at once, collaborating in real time, which produces more and better ideas and gets trailers done sooner. Now that sounds to me not like a technical outcome, but like a business outcome.
Yeah.
He is your boss, right?
Yeah.
He must be pretty happy with you.
Yeah.
Do you think I could get away with saying you were an IT hero for what you did here?
Yeah, you could do that.
All right. Anthony, thank you so much for coming. Let's give it up for Anthony, everybody. OK, so those were just 3 examples of the customer success that we're hearing about since we launched Storage Spaces Direct in Windows Server 2016 last year. 3 stories among many. Now, hopefully with those as context, it feels a little bit less braggadocious for us to assert that Storage Spaces Direct offers great performance and great value. Now, if you were paying close attention, you may have noticed that all 3 of those stories chose to go with hardware from our friends and partners at Data On, I want to thank them for sharing those stories with us. And in keeping with the theme of being an IT hero, some of you may have already made it to their booth on the expo floor. They've made these T-shirts about being an IT hero. So if you haven't gotten one yet, go check them out. They're at booth 1726. Tell them we sent you and get your free IT hero T-shirt. OK, so how did these stories happen? How did they do it? What did they use? What technologies did they use? And why did it work out so well? It's time to dive in to Storage Spaces Direct. Some of you may be familiar with it already. Some of you may not know very much about it. So we're going to start from the beginning. Storage Spaces Direct is software-defined shared nothing storage. What it enables you to do is build a lower-cost alternative to traditional storage using industry-standard x86 servers with just local drives. So to visualize what that looks like, we're going to start with just 3 servers with local drives. We have 2 SSDs and 4 hard disk drives in each of these servers. Now, I want to emphasize that these servers are not connected by any kind of fancy cables. We don't have a storage fabric. There's no fiber channel here. It's just Ethernet connecting standard servers with some extra data disks in each one. So the first thing we're going to do is, of course, we're going to install Windows Server 2016 on these servers. And then we're going to form a failover cluster. It's the same technology you've used for a very long time. Then we're going to enable Storage Spaces Direct. And that's going to take the drives from each of those servers. And it's going to go to each of the servers. It's going to discover which drives are there. And it's going to combine them into one software-defined pool of virtually shared storage. And then from that pool of storage, you can carve out volumes, which will have properties like fault tolerance and many other great features that we'll talk about throughout this session. With those volumes, which of course are just an instance of a file system, you can place your files, such as VHD files or VHDX files, for virtual machines. And you can do that in 2 ways. The first is you can expose those volumes over the network as SMB3 file shares. In this way, you're using Storage Spaces Direct kind of as a virtual NAS, if you want to think of it that way. And that's, for example, what Anthony did at Create. Or you can actually take your virtual machines and run them. You have to enable Hyper-V on the cluster, and then run those VMs exactly on the same cluster where Storage Spaces Direct is running, effectively making hyper-converged infrastructure. And this is, for example, what Eric did at King County Library. Now, one of the great features of a software-defined shared nothing storage architecture is its ability to easily scale up and scale out. Storage Spaces Direct can go from 2 to 16 servers and to over 400 drives in each cluster, which allows you to reach petabyte scale in a single cluster. At any time, you can add servers to scale out or add drives to scale up, and we will automatically redistribute your virtual machines across all of the servers that you have and discover the new drives that you've added and load balance the storage across all of the drives, redistributing your data to even things out to make maximum use of all of the available storage and all of the available storage performance. What makes this possible is the fact that it's a shared nothing architecture. It's the architecture we use in the cloud, right? The only fabric is Ethernet. So in order to scale out, all you have to do is buy another server, rack and stack it, and plug it into your switch. There's no fiber channel cables or switches. There's no full mesh of SAS cables that you have to run between all of the different machines. There's nothing that doesn't scale here. And that's really an important point. OK, now before we dive into some more features and we sort of get into the nitty-gritty of how Storage Spaces Direct works and what we're so excited about with it, there's a quick piece of kind of housekeeping that I want to call out. So almost everything that we talk about today is in Windows Server 2016 data center. There are a few things that we are just so excited about that we want to share with you today, but they're actually new this year. And so if you want to try those out, I guess one thing you can do is you can just say, OK, that's a futures discussion. Fine. Take it as a heads up. But if you want to try it out sooner, if you want to try it out now, you totally can. And you just have to join the Windows Insider program, which is free and easy. And then you can try those things out today. So we're going to do our best to label things that are not in Windows Server 2016 with that little sticker that says new this year, so you know what is and isn't in the product that shipped a year ago. OK, sound good? Awesome. I see some nodding. With that, then, it's time to dive into Storage Spaces Direct's industry-leading performance. And for that, I want to hand it over to Andrew.
All right. Thank you, Cosmos. So, as Cosmos said, we're going to dig into some of our performance numbers. All right, so let's start with IOPS. Storage Spaces Direct is capable of producing over 6 million IOPS in random 4K reads. Also, it's capable of producing 1 terabit per second throughput. To kind of put it in different terms, the English Wikipedia in text form is 11.5 gigabytes. That's the equivalent of transferring that English Wikipedia in and out of the application 14 times a second. Or in other words, 125 gigabytes per second transfer speeds. And this is all done with consistent sub-millisecond latency. Now, I am unaware of any other hyper-converged solution vendor that produces even half of these numbers. And we're pretty proud of that. And the way that we do that is really you can do it 2 ways. Number 1 is a hybrid solution where you have SSDs and mixed with hard drives, traditional hard drives. Or you can do all flash, which is SSDs only. But in both of these solutions, you notice you do have some flash. And that's really the key. Because we have in Storage Spaces Direct this built-in, always-on cache. And what this allows us to do is take random IOs from all of your applications and then lay them out in a more sequential manner before they reach the hard drives underneath. And each of these SSDs will bind dynamically to several hard drives, meaning that it's independent of any kind of pools or volumes that you create, and there's no kind of tricky configurations to do. This is done automatically. So let's do a little demo and look at what this cache is capable of doing. Some of you may have heard of Project Honolulu. This is our new graphical user interface for Storage Spaces Direct. There were sessions earlier this week at Ignite. If you haven't seen them, I encourage you to check them out. So let's take a workload. In this case, it's producing about 300,000 IOPS. You see there. And with a latency of sub-millisecond, so about 100 microseconds there. And a throughput, 1.36 gigabytes per second. And you can also, at the top right, if you want to, you can check this time series by day, by week, and even by month, if you like. But what I want to focus on more is how we're getting this many IOPS with this low latency from a system that's primarily spinning disks. So if we go down, we dig into view drives, you'll see a list of all of the hard drives. You'll go to inventory, and if we sort them, say, by type. Now, scroll, you'll see we've got lots of HDDs. You see the type HDD. In fact, there's 48 in this system. And see they're listed by type HDD, and they're used for capacity just to the right there. And if we scroll down, you'll see these 16 SSDs that we have listed by type SSD. And you'll see just to the right of that they're providing cache for these HDDs that are spinning. So if we click on one of these, which is representative of any of these SSDs, you'll see it's producing about 4,000 IOPS with sub-millisecond latency. And if we were to go back to check on one of the hard drive performances, which we'll just choose any random hard drive here, let's say this one, you'll see that it's producing about 300 IOPS for a spinning drive with 16 milliseconds of latency. Normally, you get about 100 IOPS for 4K random on a spinning drive, but we're getting over 300. So if we go back to the dashboard, we'll see here, yeah, consistent 300 IOPS. So go back to the dashboard. This is all, despite being a small amount of flash and a large amount of spinning drives, we're getting sub-millisecond latency and over 300,000 IOPS performance. So again, 16 SSDs, 48 spinning drives. In terms of capacity, that's less than 10%, 8% flash, and 92% spinning disk, but we're still getting SSD-like performance of this whole array. So we've talked about these two drives that you can have. Spinning drives, they can be any RPMs, we don't really care. One caveat that we have is that if they are behind a controller card, it must be in pass-through mode. So no RAID behind that. And then you have solid-state drives. Now, a third type that's relatively new is NVMe. It's a new protocol, non-volatile memory express. And we support these drives. And to illustrate a little bit of what the performance gains you get out of NVMe, let's take a look at just the technology in general. Now, NVMe is a flash device that sits directly on the PCI Express bus that allows it to have faster I/O directly to the chipset, instead of being like a regular SSD that has to go through a SAS fabric and maybe even a controller card. So it's just right there on the PCI bus, plugged directly into the motherboard. And if you were to compare these side by side, so let's take an Intel P3700 on the left, which is their NVMe SSD. And on the right, we have the SATA version of that SSD, both the same capacity of 800 gigabytes. And we look at their prices. In this case, this was Newegg's price last night. And if you look at the economics of dollars per gigabyte, you'd say, I'm going to choose the SATA SSD because clearly that's a better choice. It's cheaper per gigabyte. But let's look at performance. Random 4K IOPS on each server. The SATA SSDs, 95,655. NVMe, can anybody guess? 324,018. So if you flip that around and you do dollars per thousand IOPS, the economics is very different, where the NVMe being at $3.85 for 1,000 IOPS, and the SATA SSD being $7.84 per IOPS. So we really think that makes a large difference if you're looking for that performance workload. Now, CPU consumption is another benefit where this decreases using NVMe. Now, if you take 100,000 IOPS on a CPU, and any given SSD is 37%. Using NVMe, 19%. That's additional CPU cycles that you can use for your Hyper-V workloads, running applications that make your business money instead of working on just doing storage operations. And that's barely half. Now, in choosing the types of drives for your storage spaces direct solution, you can have one type of drive where there's no caching, two types of drives where the faster provides the cache, or three types of drives where one type provides cache and then the other two provide capacity. And it looks a little bit like this. Now, in hybrid, this is using, again, some flash and some spinning disks. You can do NVMe for your cache over hard drives for capacity. You can do SSDs over spinning drives, or you can do NVMe with a combo of SSDs and spinning drives. But that's kind of a niche situation. Or you can do all flash, where you can have just NVMe, you can have some NVMe over SSDs, or just SSDs, providing all your capacity. So we've talked about these three types: spinning drives, SATA SSDs, NVMe. One that's new for Windows Insiders is what we call storage class memory, namely NVDIMM. And this is available today, like I said, Windows Insiders. It's new this year. And some of the configurations that we support are straight SCM, SCM over NVMe, or SCM over SSDs. Now, that's a really exciting new technology, and I can't really do it justice in the time that we have here. So please check out this other session. It's all about SCM. It's got a lot more details than I could ever go into. But it's an exciting, high-performance, very low latency solution that we're very proud of. Now, all of this performance is capable really because Windows Server is on the leading edge of the x86 hardware innovation, meaning that we can support all of these new technologies as they come out. I've told you about storage class memory, how we've supported it, and it's available today in Windows Insiders. I told you about Intel Xeon Scalable, which we supported since the day it was announced. We've talked about NVMe, which we now support, and Optane, which we've supported since it was announced by Intel. We've also talked about RDMA, or we'll talk a little bit more about that, which is unique to Windows Server and software-defined storage, and we'll talk a little bit more about that again. And also, if you haven't seen Data-On's Kepler 47 system, that's a great example of how we're using Intel Thunderbolt for enabling new solutions where you can imagine kind of a switchless networking. So a little bit more on RDMA. What is RDMA? Remote Direct Memory Access. So CPU consumption for 400,000 IOPS, 70/30 read-write, 4K random. Non-RDMA, 50%. Turn on RDMA, and it goes down to 33%. Again, those are CPU cycles that you can use for your workloads that generate money for your business, saving about 1/3 of your CPU. In another case, if you do just 100% read on 4K random IOPS at 100% CPU, so this is kind of full bore, 956,889 with non-RDMA in this case. And turn on RDMA, 1,891,946. We use exact numbers because we are engineers. That's about 2x. Now, all of this is possible because Storage Spaces Direct is kernel embedded. We've optimized it at the kernel level inside of Windows Server. So just to recap, SSD performance because we have this built-in always-on cache. You can choose drives for all types, flash, hybrid. We talked about NVMe and the benefits that it gives you for lower CPU consumption, more IOPS. We talked about storage class memory. We talked about RDMA and how that provides increased networking performance with lower CPU, and how it's a kernel-embedded architecture, meaning that it's optimized for this increased performance. So with that, I'd like to introduce Garrett up here to talk about our enterprise-grade features.
Can everyone hear me? There we go. All right, so next we're going to talk about the enterprise-grade features on Storage Spaces Direct. These are the features that we believe provide you with reliability, with resiliency, and security for your data. So here we've listed quite a number of these features. And we're going to talk about a number of these at a very high level. If you have follow-up questions, I encourage you to look at our documentation online or come speak with us after, and we'd be happy to go further in depth with any of these topics. So first, I'm going to demonstrate how Storage Spaces Direct can tolerate multiple failures, whether it be drive, server, or networking failures, and your data can will still remain accessible and highly available. So I'm going to navigate to our hyper-converged cluster, and as you see, all of our drives, servers, and volumes are currently healthy. We're going to navigate to the files themselves, and this is just our demo volume, and here's our cluster. And what we're going to do here is we're going to upload just a test file. And this is going to serve this Ninja Cat T-Rex GIF file. And this is just going to serve as a test file to show as long as this file is accessible, all of the rest of the data, that important user data, whatever it might be, is still accessible despite suffering a range of other types of failures. So here's the hyper-converged architecture that Cosmos alluded to earlier. In this deployment, we have 4 servers with locally attached SSDs and hard drives. And what we're going to do is we're going to start introducing different types of failures and determine if our data is still accessible. The first failure type we're going to cause is just a drive failure. We're going to go to our data center, yank out a drive, which simulates a drive either failing or we've lost communication with that drive. So you look back here at our GUI, and we see a new alert. It shows that our drive, we've lost communication, and again, in our inventory tile, it no longer shows as healthy. So we can click further to learn more information, and we see we have this summary of what might be going on. Either we lost communication, or the drive failed itself. Now, we provide clear and consistent location information to where if you want to go and actually look at this drive in the data center, you can follow the location information here. And we provide mitigation steps to possibly help you resolve this issue. Then you can navigate to the drive itself and further investigate what might be going on. As you see, that same status is reflected here. The drive has been retired by Storage Spaces Direct because we've lost communication, and the performance itself has stopped, which indicates that the drive has probably failed as the time series database is no longer populating this data. Then we can turn on the indicator LED, and this works kind of in parallel with the location information that allows you to easily identify that drive in the data center. And Storage Spaces Direct allows you to easily, in one quick step, to hot plug that drive, and that new drive will automatically be added back to the storage pool and then used as available capacity. So next, we'd like to introduce an entire server failure. We're going to go just yank the plug on an entire server that simulates a server going down, or possibly that server might be in maintenance mode. So as we see here, we're tolerating 2 failures and 2 separate fault domains on different nodes. And if we navigate back to our cluster, we see this drive error is still there, but a new error is shown, and this error is of higher severity, because a server going down is probably a more severe error than just a simple drive. We provide also summary information for what might be going on, clear location information, and possible next steps for you to go and resolve this issue. I'm not going to navigate to the server itself, but just to show you that we clearly say that all the volumes are still healthy. There's a little subtlety here, as this server that went down still needs to resync. It needs the latest updates to synchronize across the server, but that still doesn't mean your volume isn't healthy. Everything is still healthy. Your data is accessible. As we see here, we have all of our available storage capacity. I can navigate back and look at our test file, the one we created earlier, and just to show you that all the data is continuously accessible, I'll go and download that, open, and as you see here, it's still running, and that means all of your important user data is still accessible and online. So what we've seen, we've suffered both a drive and a server failure in 2 separate nodes. And all of that data is still accessible and highly available. So next, we've seen failures in 2 separate types, drive and servers. But if that's not enough, we offer different ranges of fault tolerance. For here, you can specify if you like entire rack fault tolerance, and once you create data, it'll be distributed across racks themselves. So if you lose an entire rack, your data will still be accessible via those other 2 racks. And so if you really need to expand this for your deployment needs, we offer drive, server, chassis, and rack fault tolerance. So next, we're going to touch on the various resiliency types that Storage Spaces Direct offers. There's 3 distinct resiliency types that can cater to the specific needs of your organization. And the first one we're going to talk about is mere resiliency. This is logically the most simple. And as your data comes down, we'll very easily replicate it across different drives or whatever your fault domain is. So that can be your server, your chassis, or your rack. Whenever one drive goes down, you can read from your other copies, and you can actually suffer 2 simultaneous failures. Whenever you suffer one failure, Storage Spaces Direct will begin immediately repairing and moving that data to a healthy drive, so you can continuously provide this dual fault tolerance. And as I said earlier, adding a drive back to the system, replacing a failed drive is one simple step, and Storage Spaces Direct will automatically integrate that new drive back into your system and begin migrating data to that drive and use all of the available storage capacity and storage performance that your deployment has to offer. It's important to note that even though Mir gives you the best performance and it's logically very easy to understand, it does come at a cost. It's very inefficient from a capacity perspective because you have to duplicate the data 3 separate times. So for all the data that you need 3 times the physical storage just to store that data reliably. But in order to offer a more capacity-efficient solution, we have parity resiliency. This can be logically compared to RAID 5 or RAID 6. And what this does, this allows you to sustain 2 simultaneous failures, just as Mir, but it does so at a much better capacity efficiency. Your storage efficiency will scale as you add more nodes, but it does come at the cost of storage performance. Every new write requires you to recompute those parity bits, and whenever a drive fails, you'll need to read across all the drives in the system to reconstruct that data using the parity bits you had created earlier. Lastly, we have mirror accelerated parity. What this does, this allows you to add both mirror and parity resiliency within the same volume. And this will give you both capacity efficient and performance sensitive storage for your data. Your I/O will come down to the mirror tier directly, where it will be aggregated and serviced in a performance sensitive manner. And once that mirror tier fills up to a certain capacity, we'll begin destaging that data. We'll compute parity on that data, and then we'll sequentially write it to the parity tier. Now, this is all done. It's important to note that this is all done in real time. Storage Spaces Direct and REFS can actually adapt to changing workloads because this isn't periodically done. This is done actually in real time. So you have both the best performance provided to you by the mirror tier, but also all of your cold data is stored efficiently in the parity tier. Next, we'd like to announce that we have deduplication coming for Storage Spaces Direct. It's available right now for all Windows Insiders, and it's a feature that we're really excited about. It enables you to significantly reduce your hardware costs by not storing duplicated data. All of your redundant data is stored once, and in real-world deployments, we're seeing up to 95% savings. This is offered across all resiliency types, not just Flash. And we also offer checksums for deduplicated data by default. This is really important because more of your data references the same physical copies. We need to ensure that we can reliably protect your data from corruptions, which is why it is checksummed. Deduplication on REFS will function very similarly to NTFS. It'll run periodically, it'll run an optimization job to remove all duplicated data. But we want to do something a little different with REFS. We wanted to integrate with a file system directly. So we introduced this feature known as near inline optimization. So when you have a mirror accelerated parity volume, you'll actually deduplicate in line. So as your data is rotated to the parity tier, you'll both deduplicate and you'll calculate parity on that data. So this not only reduces the amount of physical storage you need, it also stores it in a much more capacity-efficient manner. It's important to note that dedupe does this opportunistically. One of the design principles of deduplication is to not get in the way of the normal operation of your volume. So if it detects that it's negatively impacting the performance, it'll pause where it is, it'll back off, allow normal operations to continue, and then it'll go and resume that job once it understands that there's less resource contention on your system. So here are the normal savings you can expect when deploying deduplication. And I encourage you to go look at our other sessions in Storage Spaces Direct, where we demonstrate we're able to get these type of savings in our own test deployments. Next, I'd like to talk about file integrity. This is the ability to checksum your file data to ensure that you can accurately and reliably detect checksums and actually go and correct that data. By default, REFS will checksum all of your metadata, but this is a feature that allows you to extend those checksums to all of your file data as well. We believe this is ideal for archival storage because that's susceptible to things like bit rot. And so what's going to happen is all of your user data will checksum. As here it's shown, the checksum is included on the right. Over time, if a corruption is introduced to your data, the checksums that we calculate and the checksum that we have stored will mismatch. And what we'll do, we'll get the alternate copy from Spaces. We'll remove that data. And we'll actually go and issue a corrective write. So your data is stored consistently and correctly across all of your copies. There's a periodic background scrubber that will allow you to go and actually make sure your data is corruption-free, and will actually issue any corrective writes that it needs to. Lastly, I want to touch on encryption. We've talked about protecting your data from failures in the data center, but we also want to protect your data from any malicious actors. So we protect both your data at rest and in transit. We offer BitLocker for all of your data at rest, so no one can come steal your drives, your physical drives, and then see what's on them. And they also offer SMB encryption for all of your data in transit. It's important to note that SMB encryption is mutually exclusive with RDMA at this time. So in order to recap, we've gone over the enterprise-grade features of Storage Spaces Direct. These are the features that give you reliability, resiliency, and security for your data. We've shown that we can sustain drive and server failures, and you can also extend that fault tolerance to the rack level. We've talked about the different resiliency types that can cater to the specific needs of your organization. We talked about how you can significantly reduce your hardware costs by including deduplication in your Storage Spaces Direct deployment. We talked about how you can checksum your file data to find corruptions and actually correct those. And lastly, we talked about how BitLocker and SMB encryption can work together to provide encryption for your data at rest and in transit. With that, I'm going to turn it back over to Cosmos, who's going to talk about manageability on Storage Spaces Direct.
Great job. Thanks. All right. Thank you, Garrett. How's everyone doing? Still with us? Great. It's time to talk about that all-important topic of manageability. Now, a little earlier, Andrew and Garrett both showed you a little teaser of managing Storage Spaces Direct in Project Honolulu. So I'd like to take the time now to give you a slightly more thorough tour of what that new experience that we're building looks like. We're going to start on the dashboard, and I'll just show you around. So we can go into servers here from the navigation on the left, and you'll see we get this summary view of all of the servers in our cluster. I can see, for example, that I have 4 of them and that they're all healthy. If any of them weren't healthy, I would see that here. And if I had any alerts, I would see that here as well. I can switch over to the Inventory tab, and I get this list view, kind of a table, that shows me the servers in my cluster. And I can drill into one of them if I want to learn more about it. That takes me to a page that's dedicated just for this server. I can see properties like who manufactured it, or what version of the OS it's running, including that cumulative update number that's so important. I can also see statistics like CPU usage, and we're breaking this down by usage by the host OS versus usage by guest virtual machines if you're hyper-converged. We have that same breakdown for memory usage, and then you can see network traffic as well for this server across all of its physical NICs, and we've even broken out that RDMA traffic that's so important, so you can see it very clearly. This is a view we haven't had before. If I scroll down, I can see all of the drives within this server. So I can see here that I have quite a few of them. It's the same cluster Andrew was using earlier. So I have 4 SSDs in this server, and I have a number of HDDs. Now this could be a server that I'm using as a scale-out file server, or I could be using it hyper-converged. It doesn't matter. I have these SSDs which are providing caching, and the HDDs which are providing capacity, as Andrew described. Now I can get kind of a clue of that because if you look at those cache drives, you'll see I don't have a gauge over on the right-hand side that shows me how much storage they're providing, because they're not actually providing storage capacity. They're just serving to accelerate I/O. But those HDDs, absolutely, they are providing capacity, and so I have a gauge and I can see how full they are. Now that's the view of the drives within an individual server, but there's another view too. I can actually just choose drives from the navigation on the left, and that takes me to a page that looks very similar to the one for servers. It shows me how many drives I have, any that are not in a healthy state, any alerts. It's a very glanceable sort of summary view. Or I can switch over to the inventory view where I get that same table experience. But with drives, because we have so many of them, we can do a few interesting things. For example, we can group drives by which server they're in. So I can very easily see here that I have the drives that are in server that ends in 24, the ones in server 25. If I keep scrolling, the ones in server 26 and 27 and so on. And you can see that I have the same configuration in each of these servers. Right? I have the same 4 SSDs in each of them. And I can group by other things too. So I can group, for example, by type. And in that case, I can see all of my HDDs in one big long list, all of my SSDs separate from that. And just like with servers, I can click in to get more information about an object I'm interested in. So I can click into, for example, this SSD, and I get a page that's all about it. I can see its location, where it's located, what slot it's in. Even some pretty rich information, like, for example, its firmware version is visible on this page in case I need that for anything. Just like with servers, we have statistics, and these are statistics that are specifically for this one hard drive. So we have IOPS, latency, throughput, and we've broken it out at this level by read and write in case that helps you to troubleshoot or whatever it is that you're doing. Just like on the dashboard, as Andrew showed you, these are fully interactive charts. So I can mouse over a particular point on the graph, or I can change the time scale to go back a day or back a week, and I can see all of that information. Now, in this case, my cluster has only been set up for a few days, so I don't have all that much history. But I'm recording it always. Just as on the server page, we had a link to the drives that were in that server, we have a link that goes back from this drive to its server. Connectivity was one of our important principles when designing the UI, and so we wanted to make sure that all of these pages were connected in the most intuitive way. Now, there is a couple of buttons we have along the top. One of them, for example, is retire. So if there's something that I see on this page that I don't like, maybe the latency is high or what have you, I can easily just go ahead and retire this drive. I don't want to do that here, but what that'll do is tell Storage Spaces Direct to evacuate all data that's on it and stop using that drive. And it's very easy. I just have to click the retire button. One more thing to talk about in the drives area of the Project Honolulu UI is this capacity gauge that we have. Now, in my case, I only have one type of capacity drive, but if I had more than one, I would simply have multiple gauges here for each of my types of capacity media. Andrew told you can have more than one, and that's where that would show up. But even just with this configuration, I can very clearly see how much raw storage I have across all of my drives, how much of it is used, and how much of it is still free space. OK, so we have some free space on this cluster. What do we do with it? How do we turn that into something useful? And the answer is our sort of third central storage object, and that's the volume. So if we go back to the dashboard and we look in the lower right-hand corner, what you'll see is we have these tiles that summarize objects for you. And I showed you servers, I showed you drives. If you check out some of the sessions earlier this week, we give a tour of what's in that virtual machines tile. But now I want to get into volumes there, which is that fourth tile. We can click in, and you'll see we get an experience very similar to what we had for servers and drives. So I could have gotten here, by the way, from the left-hand navigation, same as I did previously. I get this summary page, which shows me how many volumes I have. It groups them by their health state. In this case, I do have some alerts, so that's interesting. And just like before, I can switch over to an inventory view and see a list of all of the volumes, all of the storage spaces that I've created in this cluster. I can see certain properties called out in the table, like their resiliency level or the file system. In this case, they're using REFS so that we get all the great features Garrett talked about. Now, creating a volume is really easy. I just have to click this Create Volume button up at the top of the table. I get this small little form. I don't have very many inputs. I have to first give it a name, for example, demo. Then I can pick its size. So I'll pick 1 terabyte. We provide inline validation, so we'll tell you if the size that you've chosen is not viable. And then we have a few resiliency types that you can choose from. In this case, it's a 4-node cluster, so we can choose between 3-way mirroring or mirror-accelerated parity if we want to get a better storage efficiency. In my case, because I've chosen 3-way mirroring, I can very easily see that that size I've selected, 1 terabyte, is going to occupy 3 terabytes of footprint on physical disk. But that's OK. I've got lots of storage in this cluster. So I'll go ahead and click Create. When I do that, you'll see I get a little notification up in the top corner. I can go in and click, and I get this progress indicator that shows me as that volume is being provisioned. It does take a couple seconds, because of course we're provisioning a lot of storage. But once it completes, I'll see that new volume appear in my list, and I can right away go and click on it and get to the page that's just for it, where I can see all of the properties. So I can see, for example, that it's the REFS file system. I can see that it's 1 terabyte, like I asked for, but because it's using 3-way mirroring, that means its footprint is 3 terabytes. I can also see the fault domain awareness. So Garrett mentioned that you can configure Storage Spaces Direct to tolerate drive failures, server failures, chassis or rack failures. By default, we configure it to server, which means every copy of your data goes into a different server, and that's what's happening here. And I can even see the file path, which is where I would go to copy files into this volume. We also have statistics at the bottom of the page, as I think you can see. Now, just to round out kind of the lifecycle management portion of this, so that was creating a volume. I've also made a volume here for myself that's called Resize Me, so hopefully you can see where I'm going to go with this. We have a nice resize button. All I have to do is provide the new size that I would like. So I can say, for example, switch it to 2 terabytes. That means its footprint will be 2 times 3 is 6. And then I hit resize. Just like creating the volume in the first place, this is provisioning, meaning it will take some time, but I get a notification. It shows me progress, and then when it completes, I get notified that it's done, and I can see that the properties on the page have changed. So it's very easy to resize it, and we'll automatically extend the file system out so you can put more stuff in this volume. Last but not least, we showed creating, we showed modifying. Of course, we have to be able to delete, and that couldn't be easier. You go to the volume page, you click the delete button, it gives you a warning that says, hey, this is going to erase everything, but yeah, I know that. I'll check the box and go ahead and hit delete. And just like before, we get this notification up at the top. I want to emphasize, all of these actions are non-blocking, right? So you can, once you kick one of these off, you can go do other things in Project Honolulu, and you'll get a notification when it's done. So that shows you creating, resizing, and deleting volumes, and it gives you hopefully a taste of what managing a storage spaces direct cluster in Project Honolulu looks like. If you want to learn more, we had 2 sessions that were just about Project Honolulu. We gave like over 15 demos across these 2 sessions. We spent hours talking about it. If you want to learn more, I encourage you to go check out these 2 other sessions. The second one is actually me, so that's the one you should check out if you only check out one. Okay, managing, though, is not just about a graphical experience. A graphical experience is really important, but we also have this tremendous asset in PowerShell. Right? We have we're in this place where, I don't know if you guys know this, we cannot ship a feature if it doesn't have PowerShell. Those are the rules for us in Windows Server, which means PowerShell is laced through absolutely everything that we do, and that's really, really empowering. I want to give you 2 examples of things that I think are pretty cool that we're doing with PowerShell. The first is we've created an end-to-end scripted deployment, which we've been sharing with our OEM partners so that when they deliver a Storage Spaces Direct system to a customer, they can completely bring up the environment in a way that's perfectly repeatable, far less prone to error than sort of a next install experience, and that just reduces inconsistencies across all of their deployments. That's one example. Another thing that I think is just awesome is our field, our educators, the people at Microsoft who teach other people at Microsoft and around the world how to use our technology, they've virtualized what I would call, I don't know if they'd call it this, but I would call it their playtest lab. And they've virtualized that completely based on PowerShell scripting so that they can stand up an environment, whether it's a 2-node or a 4-node cluster, whether it's using hyper-converged or just a scale-out file server, whether it's using storage replica or it has rack fault tolerance, they can stand those environments up in like less than 10 minutes. Play around with it, see how it feels, and then tear it down in seconds and do it all over again. And that's all because we have PowerShell laced through everything that we do. And by the way, that's all open source. If you guys want to go check it out on GitHub, it's called Windows Server 2016 Lab. The guys who run this are really friendly. They would love feedback or pull requests from you, so I encourage you to go check it out. So they say it's the littlest things that make the biggest difference. And so in this release, we focused on making a number of small improvements that customers had asked us for to the PowerShell experience. And I want to show you just one example of the many here to give you a flavor for what it is that we're doing. So in particular, the new volume commandlet is a really frequently used commandlet. It's the PowerShell equivalent of the workflow that I showed earlier where you create a new storage space. And I want to show you how that works in the recent insider builds because we've made a few little changes. So here I am in PowerShell. I'm going to type new volume, and I'm going to provide first a name, like demo, same name as I used earlier, and a size, like 1 terabyte. OK, so what other fields do I need to provide? None. We will automatically set the file system to our recommendation, which is RAFS. We'll automatically figure out which storage pool to use. We'll automatically set the best resiliency type and column, and all of those other parameters that you might have been used to providing in storage spaces, we'll set them automatically. You have to provide a name and a size. Honestly, I'm not sure how we could make this commandlet any easier at this point. And that was something people asked for. And this is just one of many, many examples. But it's not just about improving the commandlets we already had. It's also about introducing new and more powerful commandlets. 2 that I'm particularly excited about are getHealthFault and getHealthMetric. GetHealthFault is how you access those alerts that you see in Project Honolulu from PowerShell if you want to do that. These are alerts from the Cluster Health Service. GetHealthMetric, well, this is actually my favorite, so this is what I'm going to give you a demo of now. Back in PowerShell, I'm going to run a commandlet that you should all be very familiar with, and that's get physical disk. So this hasn't changed. This was there before. I'm just going to pick one of these drives at random, say that one, and I'm going to copy-paste its serial number. And I don't know if you know, you can select a drive when you run get physical disk. You can ask for a particular one. So I'll run get physical disk, and I'll ask for the one with that serial number. Now I'm going to do the cool part. I'm going to pipe it into get health metric. And what you'll see is right there in PowerShell, from that object that I had in my hand, I can see the total number of IOPS that that specific drive is doing, the average latency of the IOs to that drive. I can see the throughput, and I can start to reason about things like, hey, it's not doing any reads. That's good. That tells me my workload is mostly fitting within my SSD cache. That's what I expect. Great. Now, in this case, I just showed one object, but this is completely cluster-wide. So I can run, for example, get cluster node, which will enumerate all of the nodes in my cluster, pipe them into get health metric, and I'll see the metrics aggregated from across the entire cluster. And I can easily see, for example, CPU usage, memory available. I can see the breakdown of those quantities by guest and by host. And I can see this, again, for memory, just like for CPU. And I can see this across all of the servers in my cluster. So I can very easily start to notice any inconsistencies that might jump out at me. So for example, in this case, I notice right away that node 25 has a particularly high CPU usage compared to the other nodes. And if I want, I don't have to run just get health metric. I can actually ask for a particular one. So here I've discovered some of the names by enumerating all of them. So maybe I'm interested just in CPU usage. So I can ask for the series node.cpu.usage, and I can see that value only across all of these nodes. And here it's even more obvious that that particular node, node 25, has higher CPU usage than its peers. Now, we're not just building this infrastructure for PowerShell, of course. We're building it so that it's accessible in PowerShell, but it's also what powers that Project Honolulu experience that I was showing. So we have these line charts in Honolulu. We also have these donut charts. We have a lot of rich HTML5 visualizations, and they're all powered by this same set of infrastructure. So here I can see that same data, right? I have one particular server. It's server 25, and its CPU usage is up in the high 90s, which I'm going to need to go deal with. All right, now this is where it gets really kind of cool, I think. So back in PowerShell, let me grab that physical disk again, the same one with the same serial number, and I'll print out all of the metrics that we have for it available. And suppose I'm interested in the physical disk average latency for this individual drive. But maybe I'm not just interested in it right now, because all of those values that I printed out, those were instantaneous. What if I want it for, say, the last hour? What you'll see is when I type in last hour, I get back 360 points, one every 10 seconds, going back the last hour. And I can, for example, take those points, save them to a variable, and then I can print them out to the screen and show them to you. Here they are. Here's the latency that this individual physical disk was doing every 10 seconds, going back for the last hour. They're just timestamp value pairs. And just like I showed with CPU, right, we're not just building this for PowerShell. This is the exact same infrastructure that we're building out so that Honolulu can use it. And so if I go into Project Honolulu, say I select one of these servers, like server 27, I'll scroll down and choose one of the drives, just like I showed earlier. I can go in, and these charts, this is what they're powered from, right? And I can see each of those individual points. I can see how many IOs it was doing at any given second, what its latency was. And you'll notice the timescales over there on the side, hour, day, week, month, year. Those are the things you can ask for in PowerShell. And there's great PowerShell help text for that if you want to go try it out. The whole point here is that we have this new capability that's available to insiders today where we're keeping built-in performance history within the cluster. How this works is essentially we provision a small three-way mirrored volume. It's got a name like performance history, so it's very obvious when you see it. And we do this automatically when you enable storage spaces direct. On that volume, we provision a tiny instance of the JET database. This is a component that's shipped in Windows for over 20 years. It's like the most rock-solid little database you could imagine. And because we know it so well, we don't need any input or any configuration from the user. We can manage it completely ourselves. What this means is that there's no need to set up agents. There's no need to configure anything. You don't have to manage the database or hook it up to any kind of service or enable monitoring. You don't have to do anything. It just works. It's enabled automatically when you enable storage spaces direct, unless for whatever reason you want to opt out, in which case you can do that. You can set the flag to false. But trust me, you want to leave it on, because it's really neat what you can start to see with this. It provides easy access, as I showed, to a discoverable set of key metrics. We retain the history by default for 1 year. We aggregate that history across the cluster, so there's no disruption as nodes leave or join. And also, the history follows each object. So as a virtual machine migrates from one server over to another server, you don't get a break in your history, right? We just stitch it together, even though the performance counters underneath have actually changed from coming from one server to coming from the other server, which normally that would trip you up, but we stitch that together for you. So you just get this seamless history, no matter what happens. And we're pretty proud that we've done this in a very CPU efficient and memory efficient way. We've spent a lot of time painstakingly optimizing our code, so this should stay out of your way. You should have no reason to go disable it. That was our goal. With that get health metric command that I showed, you can pipe in a cluster node, a volume, a physical disk, a VM, or even a VHD. And you can trace all of these quantities. You want to know how many IOPS an individual VM is doing? You want to know how much network traffic it's doing? You want to know how much memory a VM is using? And you want to be able to script with all of that very easily with a consistent set of commandlets? Well, we made it for you. And the whole goal here is to enable you to write more powerful scripts more easily. Now, I'm not going to read these out loud, but the reason I put these up on the slide is these are two examples of scripts that I put together since arriving here at Ignite. They're both just a few lines long. They're quite short, and they do really powerful stuff. The second one, I want to point out, sorts all of your drives in your cluster by their average latency from the last hour. And it's like a 5-line script. That's the power of having PowerShell built through everything that we do. Now, I've talked about Project Honolulu, and I've talked about PowerShell for manageability. But it's not just about new tools and new things that are available for insiders only. We're also really excited about the integrations we have between Storage Spaces Direct and System Center. In System Center, if you're a user of Virtual Machine Manager, configuring Storage Spaces Direct is really easy. When you go to create a new cluster under Fabric Resources, there's a checkbox that says Enable Storage Spaces Direct. All you have to do is check the box, and then hit Next, and it'll automatically configure the pool, everything for you. OK, you do that. Now, what about these kind of day 100 scenarios where you need to monitor it? The Operations Manager team has built a very nice dashboard so that System Center customers can easily get visibility into a lot of these same statistics that we've been talking about in their cluster. OK, so to recap what we've talked about now with manageability, I showed Project Honolulu, which is in preview today. I showed how we're not just focusing on graphical experiences, but we're also trying to build common infrastructure that both powers those experiences and also improves your PowerShell experience so that you can script and automate and get that perfect repeatability and all of those things that people love about PowerShell. One of the big items there is a built-in performance history, which we're pretty excited about. And then, of course, we have System Center integration, because we love System Center. OK, that brings us to our last section, and that is to discuss, at least briefly, cost and hardware. So what's the deal with licensing Storage Spaces Direct? How does that work? Storage Spaces Direct is completely included in the Windows Server 2016 data center license. This is a big deal to us. If you adopt a hyper-converged architecture with Storage Spaces Direct, I don't think your licensing situation for your data center has ever been simpler. You put a data center license on each host. You don't have to manage a separate SKU or a separate license. It doesn't expire. You don't have to figure out how much it's going to cost for Storage Spaces Direct separately. You don't have to install anything. It's just one SKU, one license, one product. You install it, you get Hyper-V, you get Storage Spaces Direct, and of course, you get those free guest rights. So if you use Hyper-V today at any scale, you very likely already own this. That's pretty much the whole cost conversation. So let's talk about hardware then. To procure hardware for Storage Spaces Direct, there are really 2 routes that you can go. The first is you can build your own. We have a strong heritage of DIY with Windows Server. It's something we're very proud of, and we embrace, and we absolutely support it. And so to do that, all you have to do is go pick components that you like off of the Windows Server 2016 catalog. The only caveat is they have to have passed the software-defined data center additional qualifications. But as of this summer, there are more than 1,000 components that have passed those qualifications. So this is the option that gives you the most flexibility. But what you can also do, and frankly, this is what I would do. This is what I recommend. If you want my recommendation, I would go with a pre-validated solution from one of our partners. We have a program that we've been working on for a couple years now called the Windows Server Software-Defined Program. It is the fastest route to the benefits of hyper-converged infrastructure. We've developed the reference architecture for what the ideal right-sized solution for Storage Spaces Direct looks like. We've shared that reference architecture with our partners. We've done literally thousands of hours of stress testing to make sure that you get the fastest time to value with the least risk. Our 7 initial partners for the Windows Server Software-Defined Program represent more than 70% of the on-prem x86 server market. Very likely, whoever your favorite hardware partner is, their logo is on this slide. We're also working with many more partners to bring them on, so feeling very good about this going forward. Now, to give one example of a SKU from each of these partners, here's a bunch of 2U rack servers that work fantastically well with Storage Spaces Direct. And each of these partners has more than one SKU. They each have at least one all-flash and one hybrid system with HDDs, and many of them have many more systems than that. If you want to learn more, you can go to microsoft.com/WSSD, which is Windows Server Software Defined. And you can also go to this session, which was earlier in the week, so you'll have to watch the recording. It's already up online, where my colleague Subodh talks about the Windows Server Software Defined program in a lot more detail. He walks through individual hardware configurations. He gives some examples of customer success with it, and so forth. OK. That brings us to the end of what we wanted to talk about. We've talked about some stories of customer success. I hope you were inspired by those. I love them. We gave a brief overview of what Storage Spaces Direct is. We dove into its industry-leading performance, some of its many enterprise-grade features. We talked about manageability, and finally, we went over the details of cost and hardware. That's all we wanted to share with you today. Thank you all very, very much for coming. You've been a fantastic audience. Please remember to review this session. And have a great week at Ignite. Thank you.